Cool. Welcome everybody who's joining. This is my very first conference talk, so I'm really excited to be here to be part of this conference. Today we are going to talk about TypeScript, about React, and of course the main goal for this session is going to be crafting a generic application. So yeah, let's jump to see how you can do this. First of all, who am I? As Simon said, I'm Ecuadorian. I consider myself a developer by day, and also a chess player by night. I work at the Stack Builders. We are a consultancy focused on functional programming and functional languages, but we also do cool stuff with TypeScript, Python, and other framework, other languages, and also different frameworks. I also consider myself an open source contributor. Recently, I created a semantic release plugin for uploading packages to Hackage. That is basically the package manager for Haskell. So yeah, really excited to be here today. And first of all, I want to start with a disclaimer. I really like React. This is like a use case. Like a scenario, a case studio basically. So this is probably not the best solution, but this is one of the different. I'm sure that there could be different ways of doing generic functions with React. So this is just one of them. So yeah, what do we have for today? First of all, we are going to start talking about doc typing, what and why using doc typing, and then we are going to see the main concepts, the main things that we need for creating the generic application. Of course, we need components. I created a good a cool component called switchart. You're going to see why I call it switchart, and later on we will see how to write a generic application, and of course just minor and simple, easy to understand examples. So yeah, this is going to be a simplified version of something that I built in my current project. Yeah, so let's start. First of all, doc typing. So what is doc typing? Simon was saying something about it. But yeah, doc typing is coming from something that is called the doc test, and you can see here. This is the doc test. So it says basically if it looks like a duck, swims like a duck, and quacks like a duck, then it probably is a duck, right? So this test implies that a person can identify an unknown subject, an unknown, in this case, animal, by observing the different aspects, the different characteristics of this subject, right? So this is just pure logical inference, and the idea here is checking the behavior, the different properties, and based on this inference logic, we can say basically what could be it to whatever that we are trying to identify. So this is applied to programming. So basically, if we have two objects with the same properties, with the same could be methods, could be functions, we can say basically that these two objects are are of the same type. So here we are checking these different type concepts. And why using this doc typing? We are going to see different concepts next, but I wanted to say this here because it can help us in different ways. First of all is flexibility and simplicity. That's one. Basically, our code could be simpler and with and avoid this coupling code. And in the same way, and when you do these kind of things, you are encouraging better code with different aspects of reusability, modularity, and of course maintainability. So these are like the pros of using doc typing. So we are going to see how you can implement. So first, let's start with an important TypeScript with different TypeScript concepts. The first one is type narrowing. So basically, this is a very simple process for asserting a type in a particular part of our data flow. So in this case, we have this padding that could be a number and a string. So in this specific conditional that we have here, we are basically narrowing the type to the case when this padding is just a number. So inside of this line 5, we can use padding just as a number. So we can run different functions, different number functions, such as to fix, to exponential, for example. And of course, once we are out of the scope of this conditional, we can keep treating the padding as or other type, right? So it is going to be a string at this level, and it's going to be a number here. And of course, so we can do and execute functions that are related to strings. So for example, concatenate, contains, substring. We can uppercase or lowercase this padding here, but not at this level. So basically, this is just a technique to allow us to take a type that is too broad and refine it to a more specific one. And this process is really important because for creating a generic application, we are going to use something called type predicate functions. So this is just a function that return a Boolean value and have a type syntax return. So as you can see here, we can handle anything basically. X could be anything here. We don't know what is X, but after we use this type predicate function, we're making sure that whatever is in X at that specific moment is going to be a string. So we are doing this by checking if an object, in this case this X, has a specific property or set of properties. For now, since string is like just a string, we don't have any other properties, but we can achieve the same result basically using in, type of, or could be also use. We can use also instance of that are keywords of TypeScript. Yeah, so we have narrowing, we have type predicates, and then we have type guards. So what is a user-defined type guard? Basically, this is a function whose return type is type predicate, right? So we are composing these previous concepts. Basically, that allow you to create custom logic to determine whether a value is of a specific type. So in this little example, we can we can have a pet, a little pet, right? A small pet. That could be a fish or could be a bird. So basically the idea here is if we assume that pet is a fish, of course we are going to have a property or a method or a function basically that called swim that is going to be different than undefined, right? So this explains it better. So basically we can have a pet. We are getting a small pet. We don't know what it is. Could be a fish, could be a bird. But once we use this type guard, basically we are making sure that in the scope of this conditional, the first part of the if-else statement, basically we can handle a fish here, right? And same as in the type narrowing example, we just have two options, so the other option must be a bird, right? So we can assume that pet we can execute this fly function here. So basically, type guards enable type safety for code and better compile time error checking. So yeah, this improves our development experience. And let's jump to React right now. So yeah, we are going to create just a couple of components, and then we are concatenating all of them on the switcher. So what do we need for the components? First of all, an interface, just to define the different properties that every component is going to have. So in this example, we have 5 components. So for example, here is the input or the text area that could have an ID, could have a text, could have a value. For example, here, the same thing, but we have a checkbox. So this is the model for the checkbox. We can do the same thing for a more complex component. So for example, this button that could handle different actions, right? And of course, we have different variants on the when working with common UI libraries. So yeah, this could be another option, and also we can have icon, for example. Yeah. So this is just the last example of a model of a component that could be an accordion. So basically, we can have anything inside an accordion. So in this case, we are having this property that can handle whatever that is inside. Basically, component model is of type unknown, right? So what are we going to do next? We are going to define our type guards. Yeah. So for every component in our application, we are going to define this type guard function, where first of all, CMP could be whatever, could be this unknown that we have here. So we are not sure if it is or if it isn't, but we can be sure that if this is this component, this CMP, sorry, has like all these text input model properties, the ones that we define on the models for every component. So basically, we can return a type predicate that is saying that this is going to be an input. Yeah. So we can keep this idea of checking the properties of this object using guards, and with this type predicate, with this predicate, basically we can be sure that for example, this thing here, when we are using this function, is going to be a checkbox, is going to be a button, is going to be an accordion, and so on. Of course, this could keep extending to as many components as you want. So where everything comes together in this switch yard I call it this component a switchyard because basically you can have whatever the type of comp here could be whatever. Could be a string, could be undefined, could be a null, could be a type of a text input model, could be a checkbox model, could be whatever. But inside of this component, we are making sure to render the proper component that we want, right? So this is the logic here is checking the properties of this comp. If it is true that this is a text input model, of course, we are going to re-render an input text. This logic is the same for all of this. So yeah, we can do checkbox, we can do button, we can do accordion with some extra props to these components, just to keep all the flow together. And of course, we can have this is a common pattern on React, like having a default case when you are doing some conditional rendering, that is basically all of this, and you can have a missing component, and that is going to say, like, you haven't implemented this new component, this comp with these different properties. So yeah, of course, you have to create your components just as you would for any other application. So for example, we have input text here. Of course, we know that one of the props for this component is going to be this comp, that we are making sure through doc typing and that this is a text input model, so we can use the different values inside of this component. So for example, in this case, comp that value could be a default value for this specific input, that, as you can see, this just is a pretty basic input text with some label, right? And of course, we are managing right now the internal state with a news state. Could be this also a ref, but the important thing here is that comp will only contain the model properties that we are expecting inside basically inside this condition that I just showed you in this slide, right? So here comp is of the text input model, here is a checkbox model, here is a button model, and of course here, well, of course, comp is an accordion model. So this is the way of when right now we are at the point that we created our components, we define our components, we define our switchyard. So what is missing for having a generic application? Of course, routing, right? And we are going to see just now the routing. So first of all, of course, we will need a route. This is like a pretty basic route that is using an ID as a param. So basically, you can handle as many IDs as you want. I call it apps because if you are creating a generic application, this is for me, this is no longer an application. It's more like a platform. So whatever that you are going to have inside is going to be like a little application, right? So what is the important part here? That in our route we can define this response, this res, that is basically an array of objects with all of the pages that we want to handle, and that we want that our generic application handles, right? In this sense, of course, these pages or applications, as I like to call them, can come from an HTTP request, could come from a WebSocket, but the important part here is like passing this through this component called applet. Yeah, and then what is inside the applet? We have an application that is defined, and this application have like an skeleton, and inside the skeleton we have the components, right? So what is the basically components is an array of all the different components that you want, right? And this generic idea goes mapping. When you map this array, this components array, basically you are saying, well, you have this switch chart, please check what to render, basically, right? So depending on what properties, on what objects I have here at the in the components array. Of course, I'm going to render different things on the application. So let's see an app object, basically. So as I was saying before, this is like an this has like an app skeleton property, and inside the app skeleton we have the components. It's opening here, this array, and it's closing here. So this is just a continuation. So what do we have here? We have I don't know. We have a type that is a text that could be just an static text. What do we have here in the next item of the components array? We have a type input with a text name, for example, and then at the end, just pretty basic application, we have a submit button, right? With no actions for now. So this is not doing anything, but with another property that is a variant. So I don't know, for the ones who have used MIUI or Chakra, we have different variants like outline it, contain it, could be text. So the idea is that you can define the different buttons that you want. So what is the output of all of this? What is the final result? Is that you can have a home page with your different applications. And for example, this one is the object that we just saw. So this is the static text that is saying just please write your name on the input below. We have an input with a name, and we have an outlined button, right, with the text submit. And this is just pretty basic, pretty simple, but of course you can have a better form, right? With more things, just a full name, email. You can handle phone, I mean number inputs. Could be a big text area for the comments. Also here we have checkboxes, for example, for accepting the terms of policy. And we have another type, another variant of another button variant, basically here with the same text. So yeah, basically this is like the way of you can for you to create a generic application. This is a valid pattern on the React world. So I just wanted to say the takeaways for this little talk. So first of all, doc typing can be applied to a React application, right? Using narrowing, using these type predicates, and of course using the type guards. So yeah, that's one point. The next point is, of course, React is good enough for creating generic applications. And yeah, I invite all of the React experts, the React community to change your mindset, the way that you develop React, creating a project like this. Try to make things generic, and of course, this is not all the work. Of course, we need backend support and more things, but yeah, you can achieve a generic application using using just React and TypeScript. Yes. Yeah, that's all for my talk. Thank you for the attention. If you have any questions, I'm happy to answer. And you can see here this code. Well, you can find the code with a real example with different applications of that I created here, just a repo. I don't want to get credit for these slides. This was created using SlidesGo, and also some of the images that you just saw are from Freepik. So yeah, this is it. Thank you very much.